Thanks everyone for joining today, this exciting webinar. We have some great speakers, a great topic here. My name is Chris Kazemchak, and I work in the marketing consulting with Vecta Labs. And what I'd like to do is go ahead and first of all, we'll do some housekeeping notes on this. The first one is you heard there, this webinar is being recorded. It will be available within 24 to 48 hours on the Vecta Labs website. The presentations today will be approximately 45 minutes with a total of about 15 minutes of Q&A. The chat feature is open to post questions, and we will answer those questions at the end of the webinar. So first, let me introduce our speakers for today. So you'll see them here on the screen. The first is Joe Madden. So Joe Madden, he founded Mobile Experts and serves as the lead analyst. And over the past 30 years, Joe has accurately predicted digital pre-distortion. So I'm going to hopefully get all these correct. You've done so much here. Remote radio heads, small cells, 5G fixed wireless, as well as accurate growth forecasts for IoT, virtual RAN, and open RAN. He has worked as an RF engineer and managed product lines in mobile infrastructure and in handset components. He has parachuted in as an interim CEO and returned a dying company to profitability. Joe leads the Mobile Experts team in analysis of wireless communications and edge computing education. His education is at UCLA and Stanford for physics and business. And he says he can't jump so high anymore, but he still loves to spike a volleyball. And we found that out recently with the knee surgery there. So welcome, Joe. We appreciate you being on here.
Thank you.
So in addition, we have Jonathon Labadie. And with over a decade of professional experience, Jonathon has established himself as a leading figure in the telecommunications, defense, and technology sectors. His strategic expertise is particularly evident in his role overseeing national business development and managing complex product life cycles. Jonathon skillfully navigates teams through comprehensive product roadmaps and R&D processes, ensuring successful transitions from product inception to market launch. And his career started with hands-on involvement in DAS installations, a role that set the foundation for his entrepreneurial ventures. And beyond his technical and leadership roles, Jonathon has a deep passion for music, which I found out recently when we were in San Diego at a golf tournament. And it ranges from classical to metal. And his interest in photography, particularly in abstract and landscape genres, complements his artistic pursuits. So well balanced there in artist and some technology. So with that, we are going to start with Joe. And Joe, let me go ahead and reshare my screen and we'll get started here.
Super. Thank you, Chris. Get the slides up here. Okay, so yep, that's our pictures. And then, yep, here's our poster boy for Mobile Experts. Chris did a great job introducing my company. We're a team of 6 analysts at Mobile Experts. And right now we're very focused on what's coming next. You know, how does AI impact the network? What's going to happen for 6G and private cellular, fixed wireless, satellites, a lot of these new things that are coming into the market. That's what my company focuses on. Let's go ahead with the presentation, Chris. Now, this sort of started, you know, I think it was last September when we were in Las Vegas at the Mobile World Congress, and I dropped by Vecta Labs, and they had a truck with test equipment where they were showing how they can do basically pre-testing of radios before they install them in the field. And chatting with the guys there at Vecta Labs, I told them, you know, this is worth a lot of money to the operators. And they asked me, well, how much money? And so that's sort of where this webinar came from. Is you know, for me to maybe come back with an answer to that question. What does it mean to do things like pre-testing a cell site? What does it mean to look for interference in a network and to solve those problems? And so I'd like to start today by talking about first of all, some of the practical issues with installing these radios in the field. And anybody who's actually done this, who's climbed up a tower and had to screw all these coax cables into a radio, knows how difficult this can be. Uh, in fact, let's go to the next slide. And you can just imagine being this poor guy up on top of a tower and having to screw 64 cables into the right connectors and not get them wrong in the rain and the snow and so on and so forth. This can be a difficult job, and in fact, mistakes are made. Um, it's not an easy thing to do, and so this is one of the problems that the operators have is how do they manage the process of getting that radio equipment up on the tower and working the way it's intended to work. Let's go to the next slide. So one of the ideas that Vecta Labs showed me was this idea of prefabricated cell sites, or what they call sector assemblies. And my response was that I think this is pretty good. I mean, this is, first of all, this reduces the skill set of technicians that you need to send out into the field. If you can pre-test these antennas and jumpers and TMAs and radios and so on before they're hoisted up on the tower, you can eliminate a lot of those errors in routing the cables. You can prevent dirt from getting into those connectors and causing passive intermodulation trouble, PIM. And also you can speed things up. You can deploy faster and you can do troubleshooting and repair quicker. So this all adds up. And I went back and I got my spreadsheets out and looked at some of the cost for labor for the technicians that the operators are spending and so on. And even with the fee that Vecta Labs would charge for doing this sort of pre-testing, it looks to me like every site would be much quicker to install, maybe 2 or 3 days quicker, and there would be a savings of at least a few $1,000s for every site that's installed. But I think more important than that, nowadays it's extremely difficult to hire the right people with the right skill set and the right training and the right certifications to be able to climb up that tower and get it all right. So I think the operators suffer from not just the physical time of installation, but time to market challenges in having enough staff that's really qualified to put these radios up on towers. So, in my opinion, this prefabricated cell site idea is a pretty good one. Let's go on here. Now, the other idea that Vecta Labs showed me was this idea of interference hunting. And this is something that I've done myself actually in the past, looking around for where is that interference coming from that's desensitizing my receiver. And it's incredible how many different kinds of sources are out there. There are things like repeaters and land mobile radio systems. There are alarm systems and Wi-Fi networks and even fluorescent lights that can cause interference within a frequency range that's susceptible to a mobile network. And so the range of the different kinds of sources out there is tremendous, and it can be very difficult to isolate, exactly where is this coming from. So let's look at some concrete examples. If we want to look at, how our system is being jammed, what's getting in the way of some of the signals in our cell site. I've actually interviewed many different companies on this topic, about 8 or 9 different companies that are involved in tracking down interference in various ways, test equipment companies and DSP companies and others. And I've heard a lot of stories about how these interfering sources can be extremely numerous. Within a 40 square mile area, you can have more than 100 interfering sources pop up that have a meaningful impact on individual cell calls. In some networks, this can be every 1 to 2 kilometers. And you would think you might be able to go in and just knock them down one at a time, but the problem is that a lot of these interfering signals are intermittent. They might come on and off again. Let's take the fluorescent light example. Those are notorious for being unpredictable and intermittent. And so if you're out there hunting for the interference, you may not see it one day, and then it'll come back when you leave. And then the other thing is that the interfering signal could be difficult to determine what it is. Spread spectrum signals in particular can be difficult to distinguish from noise, and so something like UWB transmitters or some of these others can be low level interference that just takes away your noise for it. It takes away from your capacity in a spread spectrum scenario, but it may be not very easy to isolate. Let's move on, Chris. Okay, now one I wanted to focus on in particular is this idea of signal repeaters. And these things have been around for a long time. In fact, I think I first used some repeaters back in 2001, back when they were really simple devices, very broadband, bidirectional amplifiers, really. And what these things do is they receive a signal and then retransmit at higher power so that a local user can have a little boost in signal strength. Sounds good in theory. But in fact, what happens often with these wideband repeaters is that they create more noise for the competing operators or even for the desired operator, and they can create more problems than they solve. So one user may think he's solving his problem with a repeater, but he's creating problems for all 10 of his neighbors. Now, in the United States, the government moved to sort of solve this problem in 2014. So the FCC made a ruling to essentially legitimize the repeaters, to force them to be more narrowband in nature, and to do some cleanup and demodulation and filtering. So, I mean, before 2014, these things were sort of a gray market item. They were quasi legal, and people just sort of looked the other way and let them be sold. But nowadays they are legal and they're used in a more appropriate way. That's in the United States. In other countries, the open repeaters are still used, and in fact, there are vendors that I've run into in Russia and China that are producing millions of these things every year. So these are cheap; they're available in many countries. And if you go someplace like the Philippines or Indonesia or India or China, you'll find a lot of these repeaters out there interfering with the network. So I just want to point out that this is one of the most dangerous sources of interference because these repeaters are designed to work in the cellular band. Their filters allow them to work in that band. They often oscillate with signals that come and go in the desired band. And people tend to locate them in places where the signal is weak. That's the whole point, after all, is to put them where the signal is weak. And so, of course, that creates problems in the downlink where you're looking for a weak signal from the base station. Okay, let's look at the next one. Now, to be a little bit more specific, I broke the interference into two different categories. One is the impact on the uplink, and that is where the receiver that's being interfered with is up on the tower. These are very sensitive receivers with very good filters. And typically, they're up on a tower or a rooftop or someplace where the interfering signal is fairly far away, at least 100 feet or more. So this uplink problem is not usually that bad. There are cases where you'll have loss of capacity and so on, but there tend to be some sophisticated tools available, including from companies like Vecta Labs, and they can chase it down. I did a calculation to sort of understand, well, how many of these interfering signals are strong enough to have an impact on the uplink at the tower, and how much impact would that have, and how much capacity would be lost. And so my calculation is that every month in a nationwide network in the United States, for example, the network would lose about $3 million worth of capacity. So that's significant. That's enough money lost in revenue to justify having a team to go out and search for interference like this.
Thanks, Joe. Well, hey, everybody. Once again, my name is Jonathon Labadie. I am here as the Business Development Director of Vecta Labs. And to kind of reinforce Joe's position on all this and all the data that he's collected, Vecta has quite a few solutions and quite a few offerings that we're working on and have really refined beyond like the trial phase that I want to talk to you about today. Prior to this, I do want to kind of introduce Vecta Labs, though, just in case you don't know who we are. We are a world-class provider of independent third-party testing facilities and mobile testing for active antenna systems. And to kind of touch on that, we are ISO 17025 accredited as a laboratory, ISO 9001 and ISO 14001. And some little bit of bragging that we like to do. These are big accomplishments that as a company and the leadership have been able to put on as an accomplishment. We're the first to develop and commercialize dual polarization electrical down tilt base station antennas, as well as RET base station antennas, and the first portable pin test set, as well as the concept of the mobile test facility. And to kind of reinforce that accreditation there, we are founded by industry veterans and with patents and applications for RF. And now we get to say that we're now covering the world with a global team of RF experts as well. To kind of jump right in, though, as far as we're concerned, our place that we like to live in is prior to entering the network, especially when it comes to prefab or sector assemblies. And that for us equals or equates to qualification testing and pre-commission testing, as well as the sector assembly side of things. But we do have the capability of working within the network after things are deployed with our cell site services. And we'll break down what all this means and how we do over the upcoming slides. Here, qualification testing of cellular equipment. This could be component testing, passive antenna, DAS, IDC testing. Really, this ends up being a very precise process. A test plan is developed specific to your needs. We cater all of this prior to even beginning testing. And the goal here is to set it up to where you have the confidence knowing that you're deploying this gear into your network, knowing that it will work. That's very important to do that. There's a lot of challenges that surround that within the industry that we're hoping to be able to address further. And at the moment, we're making good strides. We've got a lot of really cool customers when it comes to that, and we'll get into like who we've been able to do this work with over the next little bit. After that, it's sector assembly and the test of complete tower top sector or cellular sectors. Now, you can see there on the bottom right, that is an actual sector assembly that we have built for a customer. And honestly, it starts at the pallet. The steel there is constructed. Everything is basically set up like when I went to Australia and saw this, it was akin to a Rolls-Royce assembly line, where just the precision and the attention to detail that existed, even down to the torque markings on the bolts holding things together, test results for all the fiber, burn-in results, doing the firmware version update on the radios, everything is considered. And for each sector, there's just countless pages of data to support the fact that this has been tested and this is certified and verified to go within your network. It gives you the confidence to be able to do that. And then on the left of that is our mobile test facility. And this is set up at the moment. It's set up to be able to accept and test that entire sector assembly. So after all of this is constructed, there are phases to where we put this in the test facility here and just test the whole thing and troubleshoot it as we go. So if we run into problems, we stop everything we're testing and we go and retest. And if it fails again, then we stop and basically start going through the motions of troubleshooting where the problem could be, and we address it. And then to touch on site services, we do have the ability to do interference hunting, remediation, site hygiene, as well as engineering. And inside the network and outside the network, that may be a little confusing to some, but where we're coming from with that is that inside the network is everything that you are allegedly in control of. So your equipment on your network. And then outside the network would be what we would consider what Joe was talking about, like BDAs and security systems and fluorescent lights. Even your local power company has a problem with a particular portion of it that could be leaking in a frequency that is disrupting a cell site. Who knows? But we have the ability and the employees, as far as the team goes, to support here as well. And to kind of do a little more bragging, these are some of our customers. We've had a lot of really good adopters when it comes to some of these technologies that we've brought to market. And we're doing a lot of work across like specifically in Australia and the US. We're touching a lot of the major carriers, as well as some of the vendors that support them. And to kind of jump into sector assemblies, you may ask why. Why do I care? Why do we want to do this? And it's ultimately where we're at now with this is we're at this point to where the market is demanding a better, in my opinion, the market is demanding a better result. And we need to grow. And unfortunately, growth doesn't occur when you're comfortable. So I realize what we're offering here is a bit uncomfortable for some, but it is meant to address these issues. We really want to innovate here and really do care about the quality of our customers' networks. So a couple of things to touch on here would be to achieve a full RF design performance. Like, imagine having a network that you have theoretical numbers on, that you've done the math, you planned out the network, and then you deploy it, and you are really close, like really close. I know for a fact there are places on this planet that does not happen, and I know for a fact there are places on this planet that it does, and it has. The other aspect of this is, the deployment time. How long does it take you to deploy these sectors, these towers, whatever you're building? At the moment, it's quite labor intensive. To touch on Joe's point as well, there are mistakes that are made along the way. You could have the best RF technician in the world building this from the beginning. He's still going to make mistakes. We're all human. And that kind of being honest about that and accepting that as a variable is important, I think. So that deployment time does get impacted in a positive way. Even the install expense, this touches back to labor dollars. Having everything built on the ground, tested on the ground, and then deployed to your GC for them to install. It's a bit crazy how quickly a vendor can install a 3-sector site using these sector assemblies. I know it took me aback a little bit. And with this, you've got the reduced OpEx costs. So you're installing fully tested products to avoid the need to return to the site and do swap outs. I don't know that I could even quantify how many times I've had conversations about doing radio replacements after 4 days on a site, 5 days on a site, things like that. It's only the person responsible for that site deployment could have considered this prior to the build, and could have made a big impact there. And then with this is the uncomfortable part to some, is improved vendor performance. A lot of us, I'm not afraid of talking about things that make people uncomfortable, but nobody gets better in an area of comfort. Sometimes we have to push ourselves, and sometimes we're forced. And during this process, a lot of lights are shone upon issues that could exist. And that is scary sometimes, but it only helps make everybody along the process better. We only get to aim higher. And with that, improved vendor management happens. So KPI reporting on vendor performance aids vendor selection and management. With this making you better, it only supports the drive to get you into that like A+ spot, or that #1 spot with whatever your whatever your customer's looking for. Kind of move on a little bit to reinforce. These are actual photos of the folks within Sydney, the teams there building a sector assembly. It is highly controlled. and a repeatable assembly process. This is what I mean by like Rolls-Royce level assembly line. This is the team there is amazing. It was awesome being able to watch them do this, and it's even fully configurable as far as the control of the frame assembly, RF components, and cabling. A full RF path testing plan has come up. This is for insertion loss and isolation, testing for internal and external dynamic PIM, fault identification and repair. Like I said, the latest software version that's uploaded to the radio heads, or the remote radio heads, as well as the hybrid cable and connectivity to the remote radio heads. This is all verified. And the beauty of this process is that it's all discussed and meticulously planned out and put together prior to the first sector assembly being built. So this is all really intensive and really precise. And then another cool part about our kind of process, we extended the same sort of technique and principle out to how we perform just qualification testing to our customer. Or let's say you're trying to do some PIM testing on a number of antennas or splitters or whatever component you were trying to add. The same level of detail is provided at those testing levels for those products. And one of the really cool parts that I thought was awesome is the automated test process. Sorry, the Vecta test software, it fully automates the test process from start to finish, and the operator intervention is only required for the initial system verification and to connect and disconnect the test cables and the antenna ports. So the human element of, well, the technician could have done this, the technician could have done that, it's gone, essentially. It's this menu or this process is built at the same time that test plan is built, and then only implemented throughout each testing phase. And then data review, apart from the test review, our result review conducted by the test supervisor, all test data and system verification data is routinely reviewed daily by our test engineers. So you have somebody there looking at this every day, verifying things. And the data review has a focus on system verification results to ensure the integrity of the measured test results. So it isn't just the guy in the lab testing this that sees your stuff. It's another person there, another layer. It could be another couple layers looking at the test results of this and kind of trying to find if there could be something wrong, or if there was something that needs to be redone. And then another aspect of this is operator training. All test operators have undergone detailed training to ensure the detailed understanding of the test process and the importance of adhering to the standard test procedure. So this isn't something that you show somebody once and then never go back to with them. This is something that you're taught constantly, that you're held accountable to constantly. This sort of dedication isn't taught in a week. This is massaged over a long period of time. And this, again, kind of touches on the continuous improvement. We're, like I've said, everybody's human. We all have places that we can grow from. And we are very honest about that with ourselves, with our teams, and with our customers. So that's something that we take a lot of pride in. And to kind of touch on the achievements so far when it comes to sector assemblies, this isn't actually as new of a concept as it may sound to some people, because we've built over 7,800 sectors as far as over a couple of different networks or several different networks. And the other cool part about this, me talking about it's amazing how quickly this can be installed. A 3-sector cell site can be installed in 2 hours. That's happened. That's real. And when you're talking about labor dollars, compare that to the last cell tower you've built. How long did that take? Just in labor hours. That is a dramatic impact on that, in my opinion. And then this is, proven via network metrics that pre-assembled sectors are not susceptible to poor workmanship failures. We've had so much feedback that I wish we could share on a public format. But just the reinforcement we've gotten has been overwhelming for me, because I've never had the opportunity to work on a team that had such raving fans. when it comes to the products and the services they offer. And that is proven via those network metrics. The significant reduction of time required on site touches on that labor dollars thing. The return site visits has been significantly reduced. That touches on labor dollars. That touches on equipment costs. Depending on whose fault it is, the thing broke or doesn't work. It depends on whose purse that comes out of. And then network stability. This touches on your KPIs as far as your ROI on that site build to begin with. Is how stable is that network? How well does that network, that site perform within your network? And then this is touching on kind of the proven via network metrics. We've seen network performance near theoretical values as far as what we've achieved and what our customers have achieved with the sector assembly concept. And throughout this process, this is the uncomfortable part again that we're talking about, is we have seen companies and vendors of our customers literally improve to only become a better vendor. And that's something that we really like to see. I understand the position everybody's in, I really do, and I like to see growth for everybody. It's nice to not be alone when it comes to how fast we're running and how far ahead we're running. And moving on to interference hunting, we've got this really cool product that we've recently deployed as far as a test deployment goes, or a trial, called RF Seeker. And what this does, in a nutshell, and I'll go through the details, is we're addressing another uncomfortable topic within this industry that nobody really wants to talk about. I understand why, but I'm gonna shine a flashlight on it briefly. And that is, there is a tremendous brain drain in this industry. And I cracked a joke to a friend of mine several years ago about how I'm just making up numbers, one of 13 people in the country my age that care about RF. And every year that goes by, the more I kind of laugh in a scared way, because it really does look that way now. So we're attempting to address that brain drain and the learning curve that's going to happen between those people leaving the market and the new talent coming into the market, and how we educate them and how we show them how this happens. And this particular tool forensically identifies, tracks, and localizes multiple sources of interference simultaneously. And it does this using AI techniques to differentiate interferers from traffic. So that's a big deal. Being able to differentiate the interferer from traffic, being somebody I'm a little dangerous being able to interference hunt, but I've got a colleague who would run circles around me when it comes to this. And one of the things I would get hung up on as somebody who's not an expert in that particular technique is I'd get stuck potentially chasing ghosts as far as, is this traffic, or is this the noise floor? What is this? What's going on here? So that's a big factor in why this product is really cool, in my opinion. And then it's extremely effective in crowded traffic conditions where the spectrum analyzers typically struggle. So call it like a hockey game where everybody in there is using their cell phone at the same time. You have a wireless network, you have a DAS system, you have a network outside of the hockey stadium. This can identify interferers close to the noise floor. So within and beneath that traffic, basically down to the noise floor, this has the capability of being able to identify it. And then automated storage of spectrum data with easy analysis of recorded results. This is just something that happens as we're moving along. This is recording and uploading and recording and uploading. So this is just something built in. And it's very efficient and cost effective in all cellular technologies, including TDD. And this is something that we've been able to witness with these trials that we've done. It also, kind of touching on the uncomfortable topic initially, this assists both an inexperienced spectrum analyzer user, which in comparison to my colleague is me, and the experienced solo interference hunter, and that's my colleague. And you can see my colleague here on these bottom photos. It's think he had a lot of fun doing that, but we've had a lot of fun watching this product develop so far. And to kind of quantify, on the next slide, we've got some really cool figures at the end of the day. We've been able to kind of show that in that particular iteration, we've been 2 times faster at finding an interferer compared to a traditional technique. And if I remember correctly, that's with my colleague doing it. So we've been able to double his time in being able to address this. And to not skip over the cool graphics, just to kind of break this down, to the right, you've got the spectrum analyzer view, and that shows the detected interferer, highlighting the center frequency and amplitude. So you can see that little green rectangle on the spectrum analyzer view is RF seeker identifying it. You've got below that the spectrogram view, and that is of the detected interferer. It shows up the same way. And then to the right, you've got the map view of detected interferer, of that detected interferer, excuse me, shown as a level versus drive route and predicted location. That's the other aspect of this that I want to highlight, is that as you're driving through, walking through, however this is used, RF seeker drops a pin on the projected or predicted location of the interferer. And to touch on the trials, just to kind of take this home with this, is we had, if I believe, I think 8 total sites that we were able to trial, and all 8 were identified. 7 out of 8 were resolved, and the only reason why the 8th one wasn't was because of the human element. It wasn't because we couldn't locate it or couldn't figure it out. There was some resistance there. And to kind of reinforce that predicted location, less than 3% false positive rate, and then the greater than 97% signal detection rate. This is something we are all very excited about and hope to be able to share with each and every one of you, including the people that may not be here right now. But this is what we've got so far, and we want to continue to talk about it in the future. But that's everything I got. I appreciate everybody's time and attention. Thanks.
Great. Thank you. I'm going to stop sharing there. And what we will do is I'm going to go ahead and I'll keep up here to see if there are any questions. I did have a few in here, so I'll go ahead and start that out. And then again, if anybody has questions, go ahead and put them in the chat, and we'll make sure to get those as well. So one of the questions, Jonathon, starting out with you, was where has RF Seeker been trialed? So you mentioned that it had. So where has it been trialed?
So RF Seeker has been very successfully trialed in several U.S. states as well as in Australia.
Okay. And you mentioned that it's a new tool. It says, are you offering it as a service or is it just an outright tool?
So at the moment, it's just a service. I haven't been told anything to where it's a product we're going to sell. It's definitely something that we're using to reinforce our teams in-house, to just better our customers, our value to our customers.
Great. And Joe, I think this question could be for you here. Jonathon just talked about RF Seeker and what it can do. As an analyst, have you seen any other tools that could do to the depth that RF Seeker can do?
Well, I haven't seen any tools that do the whole thing. I have seen, for example, there's test equipment that you can buy that you can use in sort of manual mode, as Jonathon indicated. And some of that test equipment has been around for a while. And I have also seen some new software. There are companies that are doing AI-based software to try to identify signals better, but they don't have the rest of the equipment, the receiver and the mapping software and the rest of that. So this is the only one that I've seen that puts it all together.
Okay, great. A question then about sector assemblies. a question, and Joe, we'll start out with you on this. What are some of the challenges for MNOs to implement and to accept sector assemblies?
I think it's really inertia. They have a certain way of doing things. They've always done it this way. Uh, if they change the process and say we're going to integrate some of the antennas and cables and radios before we hoist them up on the tower, they don't know logistically how's that going to work. Mechanically, how do we lift it up on the tower? I think there's some uncertainties there that the operators need to get comfortable with, and then they could go ahead with it.
Right. Jonathan, I'll flip that over to you as well, because I know Vecta has actually done this more so in Australia. So what has Vecta done to help those MNOs to overcome some of those what Joe just mentioned, some of those hesitancies in accepting those sector assemblies?
Made it very comfortable to be open and honest about kind of what we're trying to achieve, what you're trying to achieve. I think we've had a lot more success in Australia simply because it was a little bit easier to build up that inertia, just from the perspective of like the size of the network and the capacity of the network and things like that. And that's not knocking a smaller network at all. That's just it's a little bit easier to approach a smaller MNO, I think, than one of the bigger giants here. And kind of to reinforce what Joe said, and this touches on the kind of the uncomfortableness of this. There's a story of a woman who's baking a ham, right? And she cuts the ends off of both ends off the ham. And somebody asks her, "Why do you do that?" "Well, I don't know. My mom told me that." And "Why did your mom do it?" "I don't know." And so on and so forth. You go back 6 generations, and you find out the great grandmother basically cut off both ends of the ham because it's the only way it could fit in her oven. And my point in telling you that small parable is that sometimes we do things the way we do them without knowing why. And I would always implore everybody to question, why do I do this? And please consider that when it comes to sector assemblies. I know it's uncomfortable. I know there's a lot of things and a lot of unknowns that you can't predict, but we're never going to get better until we start challenging the norm.
That's good. And then a question that's on top of that one, a question about it says, for sector assemblies, how does it all come together? Is it that you get all of the parts and put them together? Do we put them together and ship it to you? How does the process work for putting it all together?
That is dictated by the customer. If they want us to be the middleman between all the gear and purchase all the gear, that can be discussed. If they want to send us all the gear and all the equipment, that can be discussed. We are not set in stone. We are as flexible as we possibly can be throughout this entire process to just meet our customers where we are, or where they are, rather.
Right.
Let me expand on that, Jonathan. Let me ask you a little bit more because I've actually visited the truck that Vecta
Mhm.
Labs has in the U.S. here, and I've seen the anechoic chamber that you have inside the truck for over-the-air
Mhm.
testing, and I think it might be useful to walk through sort of what a day in the life would be like for a technician. If I'm a technician that's about to install this cell site, I would start on the ground with some radios and cables and things, and I would wire it up in the truck, right? I would put it in the chamber in the truck and do an over the air test. And then I would take it, I'd walk 100 feet over to the tower and lift it up on the tower. Am I saying this right? Is that the sequence of events?
No, the sector assemblies are all built within our controlled environment at our facility. So at the moment, we would build them in Sydney. This is for one of our customers in Australia. They'd be built in our controlled environment and facility from beginning to end. The way that we've kind of equipped or built out even the pallets that we house these in at the end of it all is set up to be where when you ship these via truck to the site for the contractor to build, it's set up to where nothing is going to be, I mean, short of, somebody flipping the truck, which I hope never happens, but it's set up to be the integrity of those test results are held up to that moment of reaching the site. So there's nobody on the tower site doing any testing at all.
Oh, I
It's
see.
just the contractor hoisting the sector assembly up to the top, attaching it permanently, hooking up the power or the hybrid connector, whatever setup you have there as far as that goes, and basically verifying that it's on and working. And yeah,
I think, but I do think it's cool that you have the over-the-air testing capability. And in the old days, we really didn't do that. We had, uh, we had an antenna pattern, we had a cable, we had a radio. We would climb the tower and hook them together, and you sort of hope that it's working. You do a drive test to check things, but there was no over-the-air test for a lot of the systems. Nowadays, we have massive MIMO systems that are tested over the air at a factory somewhere, uh, right? So you're able to do that over the air testing for many different kinds of sector assemblies, right?
yes,
Yes, and you mentioned both of you had just mentioned the mobile test chamber, and a question here is that available in the U.S.? Jonathan, you had mentioned obviously in Australia. Is that available in the U.S. and can it go to different facilities to test?
yes, it is available in the U.S. We do have uh, three chambers currently within the U.S. at the moment, and we can very easily scale to a larger number than that. As far as getting them, say you have a project that requires more than that, that's easily scalable to that point for us. So we'd have a potentially rapid deployment when it came to that. But yeah, it's would, available right now. I can provide whoever would like a quote today. So,
Perfect, perfect. Well, that's all the questions that we have. So we can end a little early, but before we do that, I would like to both Joe and Jonathan give you an opportunity. Is there anything that as we were going through this, anything you wanted to close with? So Joe, I'll start with you.
Yeah, one thing I'm going to take away with me, Jonathan, is you were talking about how there's very few young guys in the radio business now, and I think there's truth in that. My son is a good example. He wanted to write code. He didn't want to go into a dad's business, and it's a pretty typical story. So we have to automate these things, right? If we're not going to have the young guys out there turning wrenches, it's going to have to be a lot more automated. It's going to have to be a lot more simplified, and so that's I think a really interesting long-term trend that we need to keep in mind.
Great, thank you, Joe. Jonathan.
yeah, that is it's been a joke I wish I had never made, Joe. To be honest with you, because it's some depending on your perspective on the world, it could look a little bit bleak sometimes. But yeah, and it's the other aspect of not only do I think we need to automate this, which is a must, I do think we have to figure out how to make this stuff cool again. And I've got a couple of things up my sleeve to help support that I think Chris and I are working on, and I might lean on you a bit to do as well. But the other aspect of that too is let's get back to being okay with being uncomfortable for a bit too. Is what I'd really like to see. Innovation is not bred within comfort, and I know it is. It's a challenge to walk away from that awesome lazy boy, but like let's get up and go do some push-ups and figure out how to make this market a little bit better and come back, and then we can sit in our lazy boy. You just have to do that every now and then. So.
Awesome. Well, thank you, Joe. Thank you, Jonathan, for this very informative webinar here about interference hunting. And also, not just as Jonathan was saying, there's two aspects of it. There is the pre-network where you try to prevent it even before it goes in your network, but when it gets in the into the network, then there are options for that. So thank you both for your time today. And thank you to all the participants for listening in and for your questions today. So have a great day, everyone.
Thank you.
Thank you.